This is part 2 video tutorial the electric circuits. For this video, we're going to focus only on the calculations. We're going to focus on the series connection, we're focus on the parallel connections, and then we're focus on the combination the series and the parallel. Part 1 video we define the important concepts electric circuits. Things like the potential difference, the voltage, the resistance, the EMF, the terminal potential difference, those things. So this video is the continuous. It's very advisable or level part 1 video first, and then on this one we'll focus only on the calculations. Now the series calculations. Now let's understand what is a series. Series re no bolela ka one path ka tsela ye one. Let's say more nale the resistors. O ka kgona bona hore these resistors di a latelana ke one resistor after the other, so ke one path ke tsela ye one. But for parallel re bolela ka a branch. Let's say re na le this resistor and then this resistor. O ka kgona bona re mo re na le the parallel because this resistor is parallel to this one. So a re lebelle gore in these series connections re expect gore re be leng the important things ke lo re tshwanetse re di tsebe. Let's say for example re na le a circuit. This is just example. So o tlo tshwanela gore o tsebe gore for series connection ge re nyaka go calculate total resistance, R total e lekana le R1 plus R2 plus R3 and so on. E laola gore na le the resistors tse kae. In this case re na le resistors tse 3, R1, R2 and R3. So ge o ka ba le resistors tse 2, ge o nyaka go calculate total resistance o tlo ba le R1 plus R2. So make sure you understand this thing. And then another thing, V total e lekana le V1 plus V2 plus V3 and so on. How you can calculate the total voltage at the circuit. Let's say o tseba voltage ya this resistor and then o tseba voltage at this one and then this one. So e rela gore go nyaka find the total voltage o tlo add this voltages kaofela ga jona. And then another thing gape gore I total e lekana le I1 e lekana le I2 e lekana le I3 and so on. The total current the series connections di a lekana everywhere. Let's say if this circuit in a current 2 amperes, e rela gore each resistor here you will current 2 amperes. So for a series connections the current is the same everywhere. And then ranali the voltage divider. Sometimes these series connections maybe the voltage divider. A voltage divider everywhere. So give the voltage divider. Let's say ranali voltage 9 volts. This means this 9 volts this means these resistors do share this 9 volts. So that is why I reach the voltage divider. But let's say if we calculate voltage this resistor, we should share the voltage divider rule. V1 is equals to R1 over R total times V total. So give the voltage divider rule formula. O ka kgona tseba gore on this resistor we have voltage ya bokae. So even this one o ka dira the same thing. This means for V2 globally R2 divided by R total times V total. Let's say o na le value ya R2 ke 5, e ra re substitute ka 5 and then R total o tla bo edile this resistors J3 and then your V total let's say ke 9 and then we substitute ka 9 and then we'll find your voltage ye ya mo go V2. And then another formula is very important. Relay resistance ke ratio ya voltage and current. So this formula is very important. Sometimes we can calculate the resistance, the total resistor. Let's say the total resistor, R total, it will be V total over I total, because the total resistance. And then from this formula ya R is equals to V over I, o ka kgona go dira V subject of the formula, wa calculate voltage, and then again o ka kgona go dira I subject of the formula, wa calculate the current. This means ge o nyaka o calculate voltage, V is equals to IR, and then I is equals to V over R. So this formula is very important. O ka kgona go calculate everything. O ka kgona go find R, o ka kgona go find V, o ka kgona go find I. Lebelela this circuit diagram. O ka kgona go bona re mo re na le our cell. Re tseba gore line e telele ke positive and then e nyane ke negative. This means more na le positive and then more na le negative. And then re tseba gore the conventional current ke from positive to negative. This means current e move in this direction. And then re tseba gore in series current is the same everywhere. So a re lebelle question. Part A e re, what is the total voltage of the circuit? Because more na le our cell, and then ba re file gore ke 24 volts. This 24 volts e re botsa gore the total voltage of this circuit is 24 volts. So this means our answer for part A, V total is 24 volts. And then part B, what is the equivalent resistance of the circuit? Equivalent resistance ba no bolela ka the total resistance. Because this is a series connection, re la gore R total e lekana le R1 plus R2 plus R3, because re na le di resistors T3. Re na le 7, ra ba le 9, and then ra ba le 5, because ke this resistor, and this resistor. 7 plus 9 is 16, and then plus 5 is 21. So this means re na le 21 ohms ke the units ja resistor. So make sure you're always on the units, because re kwa se ngwala di units o tlo lose a mark. So this is our answer for part B. And then part C, calculate the total current of the circuit. Re ka shumisha this formula. I is equals to V over R. It was from this formula, ya R is equals to V over I. Ya re define resistance. Therefore, the I subject of the formula. And then because this question in yaka I total, era ore re tlo shumisha V total and then ra shumisha le R total. Therefore, our I total is equals to V total, and then V total re kry-ile gore ke 24 volts. And then our R total re kry-ile gore ke 21 volts. So re tlo ba le 24 divided by 21, and then 24 divided by 21 ke 1.14 amperes ke di units ja current. A re lebelle part D. Part D calculate the current through each resistor. Ba nyaka go tseba gore current ya this resistor ke bokae, ya this resistor ke bokae, and then ya this resistor ke bokae. But remember, this is a series connection, and then re tseba gore for a series connection the current is the same everywhere, and then our I total re kry-ile gore ke 1.14 amperes. Therefore the answer for part D e rela gore I total e lekana le I1 e lekana le I2 e lekana le I3, which is 1.14 amperes. So ke the current ya this resistor and this resistor and this resistor, because for series connections current is the same everywhere. So this is our answer for part D. And then part E, recalculate the voltage drop across each resistor. Re nyaka go tseba gore this resistor e na le voltage ya bokae, this one e na le voltage ya bokae, even this one e na le voltage ya bokae, because re tseba gore for a series connection voltage ya divider, so this 24 volts e ya mo, engwe e ya mo, engwe e ya mo. So re nyaka go tseba gore each resistor e kry-a voltage ya bokae from this 24 volts. So re ka shumisha this formula, R is equals to V over I, and then from here ra dira V subject of the formula because re nyaka voltage, V is equals to IR. So this is part E. Re nyaka voltage each resistor. Re thome ka this one. Let's say this is resistor 1, this is resistor 2, and this is resistor 3. This means our V1 it will be I1 times R1, because re nyaka the specific voltage, so re tlo shumisha I1, and then I1 re kry-ile gore ke 1.14 because current is the same everywhere. So R1 is 7, so mo it will be 7, and then from here 7 times 1.14 is 7.98 volts, get units of voltage. So this is our answer ya V1. Now re tlo lebelela ya V2 because ba nyaka voltage ya each resistor. So V2 it will be I2 times R2, and then because current is the same, re tlo shumisha this same current 1.14, and then our resistor 2 ke 9, so re tlo ba le 1.14 times 9, and then the answer ke 10.26 volts. So this is our answer. And then re lebelle V3, re tlo dira the same thing. V3 is equals to I3 times R3, then 1.14, and then times 5, and then the answer is 5.7 volts. So this is our final answer. Recalculate the voltage ya each resistor, and then because this is a series connections, it turns out or o ka kgona calculate voltage ya each resistor wa shumisha the voltage divider rule. So ge o nyaka calculate V1, o ka no re V1 is equals to R1 over R total times V total. So o tlo kry-a the same thing, o shumisha the voltage divider rule, wa substitute ka value ya gago ya R1 which is 7, and then your R total is 21, and then your V total is 24. So ge o ka re 7 divided by 21 times 24 it will fa 8, and then our answer for v1 re kry le gore ke 7.98 no ba the same thing no ba le gore ke taba ya rounding offs. So 7.98 and 8 di approximately the same. So ge o nyaka go calculate v2 o tlo dira the same thing, and then wa substitute ka r2, and then r total ke 21 and then v total ke 24. So it's all up to you shumisha which method. And then ge o ka tšea value ya v1 wa adda le ya v2 wa adda le ya v3 di tlo tshwana gore go fe 24 volts, because re a tseba for a series connections v total is equals to v1 plus v2 plus v3 and so on. So ke the important things tse le re tshwanetse di tsebe for this series. And that's it for this problem.